Hey, this is Alireza. In today's video, we're going to configure EIGRP Named Mode, the newer version. In addition, we'll learn about some new modules that are working with EIGRP Named Mode only, and we also learn about some additional concepts that are very important in EIGRP. And we're gonna configure all of them in the scenario, and that's why in the previous video I told you that this video is very practical. Don't lose it. Okay, now my question is, what's going to happen? What we learn from this scenario? Well, we firstly configure EIGRP Named Mode with best practice. Guys, I have nothing to do with other tutors or other tutorials, but I'm doing my best. I'm going to configure EIGRP Named Mode from my experience, not theoretical concepts, okay? But you can rely on this configuration. Don't worry about that. In the next stage, we're going to make sure that the participated interfaces that are on and ready to implement EIGRP on them. This is so practical, guys, because I'm also teaching you how to turn off that EIGRP interface to cut off the scenario and putting so much conflicts on the topology. But I teach you that how to fix it again. That's very fun. And in the next stage, I'm gonna teach you how to optimize your resource of the router's usage, including CPU, RAM, and etc. And as you know, that it is very important because you may have to work with many routers in enterprise environments, who knows, and you have to optimize the usage in each routers of your topology, and you will be a hero if you optimize your usage, all of the routers usage, right? And in the next stage, we're going to learn a little bit about security, and I will tell you that what is going on with the topology and what device has to receive the information about the EIGRP topology and what device or what zone shouldn't receive the information about your EIGRP. And it is 100% practical, and I'm going to teach you how to increase your security in EIGRP topology, all right? And in the last stage, we're gonna learn about troubleshoot, and you will learn how to T-shoot your topology and learn about your topology. And guys, some of you may say that troubleshooting and using with the show commands is not that important. Guys, let me tell you, you're supposed to know about all the information about the company that you're working in, and you have to make sure that all of the things are working well. And sometimes that problem happens in your topology, and you have to have that art to use with the show commands to know about the information and know what the hell is going on in this topology to resolve the problem, all right? So you have to give them resolution and solution at that time, and you're supposed to know all the information about your topology. And some companies, but sometimes they gives you some task that to expand the network and topology to add some routers because you have more customers in your company, right? And you have to expand that network, and then you have to configure it, right? Still, you have to know about the information of the topology, and you have to have that art to know the information about your topology, and then you're able to configure the other devices to add them in your topology, right? Now let's jump into the laboratory. As you can see, just like the previous laboratory, we have 4 routers here. Router 1, router 2, router 3, and 4. And there is some LAN or PC or I don't know, the customer, others. There is some network 10 here. and we're supposed to see that network 10 from router 1 right here. Okay, let's start from router 1. To configure named mode, router EIGRP, just like the same with classic mode, but in named mode you have to specify some name in the router, right? So I name it CD1. Why I name it CD1? Guys, you can define any name you want, right? But in this case, because I want to show you that name in EIGRP router is not necessary to be the same and the equivalent in all the routers, I'm gonna name the different name in each router. For example, because this routers, we pretend that this router is in CD in a different spot, I'm gonna name it CD1 because this is R2, all right? Router CD1, and then we have to configure address family. And then we define IPv4 or 6. We don't have to do with IPv6 right now, and IPv4, and then autonomous system. We still have AS number right here, guys. And you have to define this AS number just the same, just equivalent in each router. If you, for example, 10, you have to define, if you define 10 AS number router 1, you have to define 10 in the rest of the routers, all right? Just like classic mode, the traditional mode. And then it's time to define our router ID with EIGRP router ID. Listen, guys, this part is not necessary and it is not part of the condition to establish the neighborship, but this is completely optional. But I'm in habit to define this optional thing to troubleshoot that easier in the future. So I recommend you to define your router ID in the topology. Okay, I define this router ID because we are in R1. I define it 1.1.1. The template is like IP address. 1 and enter as router ID is defined, and it is time to specify the neighbor networks, right? The first network is 10.10.10.0, the neighbor with router 2, R2, right? And then subnet mask. Guys, if you remember in the previous video, we defined the network with wildcard mask, but in named mode, just easy define subnet mask for your network. All right, in second network is 20.20.20. The neighbor with R3, router 3. And then now it is time to make sure that the participated interfaces are on and ready to work. So before that, I'm going to show you what interfaces are participated in EIGRP topology, which show IP interface brief. And then, as you can see, gigabit Ethernet 0/0 and 1/0 are participated, right? So now we have to get into the interfaces to turn them on, to make sure that they are working well. AF interface, to get into the interface, we have to type AF dash interface, right? We have two options. We can get into the interface with gigabit Ethernet 0/0 and with no shot, we turn them on one by one. And we have another easier way that get into the interfaces with default. So it's supposed to be all the interfaces that are on into the topology. So we're going to inform the router that all of the EIGRP interfaces that are participated in the topology with no shot, we inform the router these are in the play, right? So after no shot, we have done with this router right now, and right, sorry, we get into router 2, just do the same here, router EIGRP. You can define any name you want, guys. Name in named mode is not part of the condition for establishing neighborship, right? But because I wanted to show you that name is not part of the condition, I name each of the router differently, right? And for example, we pretend router 2 R2 in another spot in CD2, for example, right? So I named this EIGRP router CD2, and then we have to configure address family, IPv4 and autonomous system. What was the AS number in router 1? Right, 10. And then it is time to define our router ID, which is optional and not necessary, but I recommend you to define that first. EIGRP router ID. Because we are R2, I'm going to define it 2.2.2. It is time to specify the networks, the neighbor networks. The first networks is with router 1, right? 10.10.10.0 with subnet mask. Great. The second one. As you can see, new adjacency is discovered and the neighborship is established. Great. And the second one, which is connected to router 4, we specified that with subnet mask. And then we have done with this router either. Oops, I forgot about that, to make sure that the participating interfaces are on or ready for work. So I do the same here, guys. We get into the router EIGRP. What was the name? City. If you don't remember the name, you can easily with show EIGRP protocol. You can see the string that you specified for this router, EIGRP IPv4 address family, and what was the name? It was CD2. So for getting to the router, easily router EIGRP, what was the name? CD2, and then address family, IPv4 autonomous system. 10. And then we get into the interfaces that are participated in EIGRP topology, right? With default. With AF interface, guess what? Default. No shot. We inform the router that these interfaces are not supposed to be off. Right. Let's jump into router 3. Do the same very quickly. Router EIGRP and a name. Any name you can define, guys. I repeat that. But because we are in router 3, in district 3, in city 3, for example, in different spot, I name it city 3. No difference. And then address family, IPv4 autonomous system. And you have to define this AS number, just the equivalent in all the routers, right? So in this case, it is 10, and then we specify our router ID, EIGRP router ID 3.3.3, specifying the networks. As soon as we specify the network with neighbor router 1 with this IP, it says that the neighborship oops, sorry. I made a mistake, guys. We have no neighbor with this IP. Sorry. We remove this network first, and specify the right network, which is the network is connected to router 1. As you can see, it is 20.20.20, right? Very quickly. And as soon as we specified this network, the neighborship is established and ready to work. And the last network is the network is connected to router 4. And we make sure that the interfaces are up with AF interface default, no shot. And right. Let's jump into router 4. Router, very quickly guys, EIGRP, the name, because we are in router 4, it is CD4. We pretend it's in CD4. CD4, what was it? Address family IPv4, absolutely v4, autonomous system, which is 10, and then router ID 4.4.4, and then specifying the networks. How many networks we have in this router? Router 4, we have 3 networks, right? 30.30. First neighbor is, as soon as we specify this network, the adjacency, new adjacency is discovered, and the last network with router 3 is established now. And then we go into AF interface default to inform the router that these interfaces are participated in EIGRP, right? With no shot. Guys, if you want to cut off the scenario and putting so much conflicts in your topology, you just have to type shot when you got into interface, EIGRP interface default. With shot, all of the neighborship are going to be down right now. As you can see, now your topology is not working well. And if I, for example, inform the router that to establish the neighborship, I can easily type no shot. And after typing no shot, they're going to up again, and the adjacent and neighborship is going to be established again. But I'm going to turn them on one by one, not by default. All right, we exit with AF interface. What was the interface that we connected? It is gigabit Ethernet 0/0 is connected to router 2, right? With gig 0/0 with no shot. We inform the router that this interface is in the game, right? And we going into with exit and then AF interface gig 1/0, which is connected to router 3. We inform the router that this interface is supposed to work. It's in the game with no shot. And as soon as you know shot, the neighborship is established and ready to work. Great. And we have another network which is connected to network 10. I forgot about that. I almost forgot that. Again, if you don't remember the string that you named for this router, which show EIGRP sorry, protocol. As you can see, this router EIGRP is named city 4 with router EIGRP city 4. And then guess what? Address family IPv4 autonomous system, it must be 10. And network, which is the network is connected to to network 10, to the PC. This PC can be firewall, FortiGate, router, anything, but this is outer, this is foreigner. 10.0, and then we have done with this router, but as I told you in the plan, we have to increase our security with the topology with some tricks, right? Guys, I have some question for you. What is the device behind our router 4? I mean here, this interface, 3 gigabit interface, gigabit Ethernet 3/0. What is that? It is connected to others, to the customers, to the branch, whatever, right? So this network 10 is not part of our topology. It is the outer. And this interface, this link, this zone is not supposed to receive our information, right? It is not supposed to get our topology, EIGRP topology information, including hello, packet, query, update, acknowledge, anything. So if we let it be, the customer, the outer, can listen to this port very easily, right? And it can take some exploit from it. And that's why we have to make this interface passive. You have to. We have to get into the router again, router EIGRP. What is that? City. We pretend this router is in city 4. City 4, address family IPv4, autonomous system 10, and then we get into the right interface, the specific network interface. What's that? It's gigabit Ethernet 3/0, right? With AF interface gig. What is that? Right now we are in EIGRP interface 3/0. With this command, you're going to turn this interface into passive. What passive means? It means that this interface is supposed to, how to say, we inform the router that not to send our information, our EIGRP information about our topology to the others through this interface, right? With passive interface. And then this link is secure right now. And right, and all is good. And if I go to router 1 with ping 192.168.10.10, it's not working. We're gonna troubleshoot that, right? With show IP EIGRP topology. And as you can see, guys, all of the networks are installed successfully except network 10. And we have to discover, we have to troubleshoot why network 10 is not installed in router 1. That we see there is something wrong here with router 4. So we quickly jump into router 4. We gotta check out another thing. We show EIGRP, and guess what? Address family, and after address family, we input neighbor. You can see the, IPv4 first, and neighbor. You can see the neighbors. Guys, the neighbor with network 10 is not installed yet. There is something wrong here and we have to figure out. I'm going to pause the video to figure out what's the problem. I think that's because of the emulator, I don't know, but I'm going to continue the video after troubleshoot that and what's going on. I tell you why this happened. Okay guys, I figured out what was the problem with the topology. We configured pretty everything right, but it was a bug from the iOS with emulator, and I resolved it with shot and no shot the physical interface, not EIGRP interface. So I get into the interface, specific interface which is connected to network 10 with gigabit Ethernet 3/0, and I shot and no shot, and problem is solved. Stupid iOS in emulator. But I have to tell you, in real environment with physical appliance, you will never face this problem, I guarantee it. Cisco is pretty stable and there is no way to face this problem in real environment. Okay, nice. I'm going into the router again. Router EIGRP. That's what? CD4. And that's why I told you that troubleshooting and being able to work with the show commands, it's very important, guys. And get into the configure address family, IPv4, autonomous system is 10, and get into the AF interface, EIGRP interface with gig 3/0, and turning this interface passive with passive interface and right. If I go to router 1 again, show IP EIGRP topology, as you can see, network 10 with this IP is installed with feasible distance 3328 is the feasible distance and the metric. And because we have two links with the same bandwidth number and delay, it's gonna be load balance with two ways. So we have two successors. So it's gonna be load balance with the same metric, the equivalent metrics. And another thing we have to check it out is ping 10.10. This stupid LAN. It wasted my time and your time. I'm sorry, but it has a lot of advantages for you because you can figure out how to troubleshoot, and how to troubleshoot is very important in your job. No sad, no regret. And another thing we want to discuss about is hello and hold time. Guys, if you remember my previous video and dive into EIGRP video, hello and hold time are not the condition for establishing neighborship. And if you, for example, change hello and hold time for router 1, the neighborship is not going to be down. So it's not part of the condition. But I want to explain why we should change our hello and hold interval time in our topology. Well, you may have to use internet between two routers in your topology, in your scenario. And as you know, that the internet link maybe that's the small number of bandwidth, and you don't want to waste that bandwidth for EIGRP packets. EIGRP by default send and receiving hello packets every 5 seconds, guys. And the hold time must be 3 times bigger than hello interval time. And if you want to, for example, change your hello interval time, you have to change your hold time as well. And we pretend that these routers are connected to each other through internet link, and the bandwidth is limited, and we don't want to send and receive hello packets every 5 seconds. That's crazy. So we're going to change and increase the hello packets, and after we changing that, we have 2 points in this scenario. Number one is, so as I just told you, that the bandwidth is not going to be wasted, right? And the point number two, as it is very important, is if we do that, we reduce the router resource usage, right? So the router is not going to calculate hello and hold packets every 5 seconds, right? So we increase the hello and hold packets. So for changing hello packets, we're going into conft again. We get into the router EIGRP. What was the string? It was CD1 because we are in R1. Address family IPv4 autonomous system is 10. And after that, to change your hello interval time, we have to get into the interface, EIGRP interface with AF interface. What is the interface? This is connected to router 2 is G0/0 with G/0. Geek 0/0. And after getting to the interface with hello interval, you can define the hello packet that it's calculated by second. You have to input in second. So by default it is 5. So I change it, guess what? I change it 10, for example. As I just told you, you have to change your hold interval time as well, and if you change your hello interval time, you have to multiply your hold interval time by 3. So your hold time is gonna be, guess what? Must be 30. 3 times bigger, right? And after that, if I show IP EIGRP topology, you can clearly see that your topology is not down and neighborship is working still, right? So hello and hold time is not part of the condition for neighborship. To show hello and hold interval time, you have to show IP EIGRP interface detail of the interfaces, right? And as you can see in Geek 0/0, which is this link, hello interval time is 10 and the hold time is 30 that we just changed. And the another interface, as you can see, hello interval time is by default is 5 seconds and hold time is 15. But I recommend you guys, it is not part of the conditions to establish neighborship, but if you change hello and hold interval time in one interface, you should change connected routers. All right, for example, in router 2, you're gonna change hello and interval time for gigabit Ethernet 0/0 in router 2 because it is connected to the interface that we just changed the hello and hold interval time, right? You should do that for better performance. And then another thing, is important is IPv4 neighbors. Is very important, guys. For example, if I go to router 4, which show EIGRP, as you can see, there are two neighbors, neighbor with router 2 and router 3. And if I, for example, see the hold times counting, IP EIGRP neighbors. Here we go. Hold time is counting, guys. Hold time is counting. This was a concept about hold and hello and hold time and what are the benefits, and you have to consider it in your topology. Thank you guys for watching. I hope you enjoyed that. Please subscribe and like my videos. It means a lot for me. It's gonna be something, right? I'm gonna make more videos and concepts. Thank you. I see you in the next video. Goodbye.